Yesterday?
It was at like,
So you got it yesterday saying it was going to be available
it
tomorrow?
was like during school I talked to them.
Yeah, that's what I did. Alright, so it's okay, we'll get to it. Okay, what'd you guys come up with?
15.
6. How'd you get 6?
Oh, there's a little spider on here. Never mind.
Yeah?
8 divided by 4 is 2, and 2 times 3 is 6.
8 divided by 4?
Yeah, because of proportions and stuff.
I see what you did there.
You might be
Okay.
wrong.
So you guys, no, it's not wrong at all. The proportion is absolutely correct. And it's kind of easy to see here because one is bigger than the other, right? Sometimes what will happen though is those will get so close to the center that sometimes you can't tell which is the big part and which is the small part. So, and there's nothing wrong with what you just did. So if you took, so what'd you guys do, 8 over x?
8 over 4.
8 over 4? Oh, I see what you did there. Okay, cool. Just multiply it. Just multiply it, keep it simple so that there's no mistake here. What is 8 times 4? 32. And that's going to equal 3 times x. That's what you really want to do here. Okay, and obviously that's not the same. Okay. Because what you're supposed to do is take the big one. What your ratio should have been was 8 over x is equal to 3 over 4. Okay? And I think you can see it on the sheet I gave you. If anybody wants one of those, there's a couple of green ones over here. It's on cardstock. Feel free to help yourself out with that. Okay? So it's kind of tough is what I'm saying here. You know, the instinct is to try to kind of want to do that from what we've been doing. But with circles, you really want to be careful there, okay? So my recommendation to you once again is simply multiply within that same chord, okay? So take 8 times 4, and that's going to be equal 3 to 2. So once you divide both sides by 3, 3, x will be that quotient, which is how much, guys? 10 and some change? 10 and 2/3? Okay. I know, and it's weird because I made up the numbers. It's weird because I made up the numbers. Okay? But that's the way you really want to do it. And again, if somebody wants one of these sheets, it's really nice to kind of reference. It's right at the very bottom. Don't go right now. Don't go right now. Well, you're already halfway there. Here, take this one. Okay, cool. All right. So again, just be very careful here, please. Multiply within the chord. That's going to give you the proper proportion. Okay. Questions on that? Sweet. All right. Let's go. Let's do a little review real quick here. Central angle. Let's go with 40 here. Let's call this x. And we're going to call this y. Okay, so what is x, what is y? Yeah, go ahead and put in your notes, stuff that you're doing right now. What? You got one, Jacqueline? Savannah, what is x? 40, good job. What about y?
20. Wait, no. You said 30. It's 20.
It's 20.
Oh, you scared me.
I'm good, huh?
Because I said it out loud. No, I already knew it. I was like, nah, I'm right.
Good, yeah. I'm going to do that to you.
You did do really hard with that.
Did I get you a? I don't even remember. I'm
Oh
sorry.
yeah, you just played a mind game on it.
I don't even. I'm sorry. I don't remember, but I hope it was a good.
I
one.
bet you remember.
I bet he never forgot. Okay, cool. Yes.
Do you remember when Alicia was wearing a watch and you were like,
Oh,
that
God.
is getting in my eyes. You need to take that off. And they argued about it for like 15 minutes.
You take yours off. I don't even. Yeah.
And
That
you were like, it's better than mine, so take it off.
it's better than mine. So take, is that what I said?
Yeah.
That's so stupid.
That would be fun.
All right, cool. I want to talk about some angle measurements at this time. Okay. So we're going to talk about whether it's two chords or two secants that intersect each other. For example, let's call this the center, but I've got a chord here and I've got a chord here, and we'll say that this is we'll call this 10 degrees from here to here, and we'll call this piece, I don't know, 24 degrees from A to B. We'll call this CD. So what you'll see is, hey man, if you've got these two chords that are intersecting each other as such, what is the measurement of X and what is the measurement of Y?
Would they be the same?
So Y is 10? That's the first thing we want to kind of see, right?
I don't know.
But understand, that's not a central angle, is it? So it can't be 10.
Half?
Half of what?
10.
So here's the rule. You guys ready? It's a really simple rule, actually. It's the sum of both arcs. So 24 plus 10 divided by 2.
Fun.
And hopefully if I did that right. Did I do that right?
Yeah.
Just 17 degrees.
That's
Okay,
okay, Michael.
Well, that's X. That's X right here. That's X. And someone said, is that both of them? And I'm going to say, yeah. And you're going to tell me why.
Why?
Nice and loud?
Why?
They're vertical angles.
Oh my God.
They just go, oh yeah. So yeah, so X and Y are both 17 because they're vertical angles, and vertical angles are always congruent.
Boy.
Congruent.
Oh boy.
What do we call them?
I call them, they're just interior intersecting lines or chords or whatever you want to call them. Because they don't have to be chords necessarily. They can be two secants. Okay? But they're just intersecting on the inside. I call them intersecting on the inside. Okay? So, simple enough? I guess? Don't guess. No.
Well,
Can I do it? Can I not? Okay? Let's try this again.
Okay.
Michael.
Okay.
Elijah said it first.
Do it.
Michael got used to it from me though.
Yeah.
Two X's.
Wait, is that both X? Is X and X?
Yeah, they're both X this time. How do you do that one?
Wait.
Wait.
No, I knew, but I thought you didn't know though. You didn't know.
But you didn't.
I thought you didn't know that you put two X's.
I did it. I can't fool you anymore. I can't go X, Y. You guys already know, so why do you try to? Someone's going to call me on it. I say no names, OTT. Why are you using two different variables if they're the same thing? I can already hear him saying that.
Michael, you think you know everything.
Okay, so what do you guys got here? Yeah, it looks like they add up to 50, don't they? So you divide by 2, you get 25, so X is 25. And so is the other X. Both X's are 25, okay? Alright, so. Are we cool here?
Yes.
All right, so
Yeah, you're right.
that's one of the two scenarios, right? If they cross on the inside. The other scenario would be if they cross on the outside, right? So let's take a look at a couple of things that are crossing on the outside. And I first want to introduce this part, which is, glad you can make it. We're going to start with the with two tangents, okay? And because I want to talk about that a little bit, which is a really, really cool rule. I really like this rule. Here's a tangent, right? And it just touches at one point. We'll call this point B. And I just made up that point, so it doesn't matter. And then there's another tangent. Woo! If it crosses inside, just fake it a little bit. And then there's another tangent here. We'll call this point C. Everyone cool with that? Now, both of these tangents intersect at the vertex. We'll call it vertex V. Everyone cool with that?
Yeah.
So can everyone imagine the scenario here? It's a circle, we've got two tangents, and they intersect. Here's what's really cool. If this is, let's call it OTT units long. If segment BV is equal to OTT, then so is segment CV. Isn't that cool? So I'm saying that this segment is going to be the same length as this segment.
Oh, yeah, I see how that works.
And that proportion will never change. You know what? Let me see if I can do it with Geo Sketchpad. I wanted to do it yesterday, and
Did it work? Okay,
no,
show us the orange.
someone asked a question, it spaced out. Yeah, what's up?
Like, what do you call like the rule? Like, is it just like the two tangent rule? Like, wait.
It's
Does it have a name? So I'm asking. Like, if we're
Well,
talking
if we had to
use
name
the
it-
tangent rule.
if we would have to name it, it would be intersecting tangents.
So it'll be the same thing, like even though like say C is like higher, like up on the circle.
Well, see, that's the thing. If C is higher up in the circle, is it still a tangent? See if I move.
I mean like on the one like yeah like.
Here, and that's why I want to show you with the other one, okay? So let me see if I can do this real quick. I know I can make this work. So hold on.
Over here.
So here's a circle. Bam. There's a point, and I want to put another point on the circle. So let me put another point on the circle, and I want to put another point out here somewhere. And what I'm going to do is I'm going to construct a line. So let me, from here to here, construct. So there's one line, and then from here to here, I want to construct. Actually, I don't want to construct a line. I want to construct a tangent. So let me see. Can I do that? Edit. Okay, I guess I can't.
That's great, Alberto. I'm glad you're born.
We can just imagine it.
Oh, see that's. Oh, that wasn't even on the circle. What the heck? I thought I saw the circle light up.
Perfect. I feel like I'm making weird spaces, but I don't even know.
Now I don't even know what I want to do now. Okay. Construct a nothing.
Should get that color.
All right, I guess I can't. That's probably why. So your question was, what if C was up here, right?
Yeah.
It's not possible to do that. They would not be intersecting there anymore. So I would have to create a tangent, and they would cross at this point. But you see, this distance and this distance then would be the same. So you can move that, but then it's going to simply shift around there. You can move it out, forward, but those distances are the same. So if this is C here, then they would just cross at another point. If I move C to here, then I would have a line that kind of does this, but then this piece and this piece would be the same. Do you see how that works? So it's just two intersecting tangents. Okay? Cool beans? So, tangent, tangent, 5x. How much x? That's simple. Cool?
Wow.
All right. Now, let's do this. Circle.
Circle.
Secant.
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 Another one.
Two secants.
Another one. Yep.
50 degrees in this arc from A to B. CD, the arc CD, has 30 degrees in it. So arc AB is equal to 50 degrees. Arc CD is equal to 30 degrees. Question, how much is angle X?
I'm still writing things down.
Okay.
That's true.
30.
Yes. Okay. No, this is a whole new example. So this is a very different scenario from what you've done. I've got to learn you this real quick. Okay. So let me pour my knowledge upon you. The first time that we did some lines that were intersecting with angles, they intersected on the inside, correct? And what did we do when they were intersecting inside? You added. So the two arcs were added, and then you divided by 2. This time, the two lines are intersecting outside of the circle. Okay? So here it's gonna matter the order that you do it in, because if you add on the inside, then you subtract on the outside. Absolutely. If you add in the inside, you subtract on the outside.
We're subtracting right now.
So this is what you're gonna have to do. It's gonna have to be the major arc minus the minor arc divided by 2 gives you angle X. So in this case, it's going to be 10. So very similar processes, except when they intersect inside, you have to add. They intersect on the outside, then you're going to.
So if you do the opposite, then why don't you multiply instead of divide?
Huh?
Like you do the opposite of addition, why don't you do the opposite of division?
Because division is.
No, before it was multiplication.
I know.
Because division.
She was like, I know.
Here we added.
Added and then divided by 2.
Oh, I see what you're saying. It's still two angles that we're trying to find. We're using two angles to get the one that's inside. So what's happening is these are getting smaller and smaller, right? So it's really the average of these two angles. Okay? When we go over here, it's still two angles, and it's the average of their differences. Okay? So we're going to subtract the 2 and divide by 2. Okay? Same process for both. I see what you're saying there, though.
Oh, she's talking to you? Well, I'm sorry.
Do a golem real quick.
My sister was so lucky to her teacher's class like that. Her teacher would tell her she gave her nightmares. She had to do it.
No numbers, people.
We're doing math, Michael.
Find X, please.
Wait, what is X?
If you have
X is over there. Find it. What is the value of X?
Like, but where's X?
Is it X that part? Is the X the Whoa. No, it's half course. Yeah. It is.
How would you know if it's going through the center?
Because it's diameter.
What else do you want? Do you want to say hi and give it a kiss? That's the dot is the center of the circle. And it's, you're thinking too much about it, my friend. Don't do that to yourself.
Yeah, Michael, quit thinking so much. You got an awkward face.
So what is X? 180. Beautiful. Okay, so one thing that I also want to mention. Let's do this one real quick. You guys ready? No, I'm not ready. And I know it's not drawn correctly. You know what? I should draw it correctly. I'm going to try to draw this correctly, so commentate. Let's see here.
You know that's what you do. No? Yeah, you do. What is it? Yeah, you do. Mine? Do you? That one, like... It's like a dance.
They're so straight!
So sad.
Here's something else that's really cool. If a tangent line and a radius or diameter meet at that point of tangency, then the angle created is 90 degrees. If the radius and a tangent meet at the point of tangency, then you've created a right angle.
So if radius and tangent meet at the tangents.
The point of tangency. Okay, so they have to meet at that point of tangency. Yeah, and someone said, well, what if I move the radius? Well, if you move the radius, let's say you pointed the radius in this direction, then they would have to meet at this point, wouldn't they? And this would have to move. So is it still a tangent?
Nope.
Nope.
Although you can do it like this.
You could create another tangent here, yeah, but then that would create 90 degrees. But does this create 90 degrees? No, and that's the idea. Is like that's what you're saying. Well, what if I move the radius?
That's not a tangent.
Then it's not a tangent anymore. Exactly.
It's a chord.
It's a Honda chord. Cool beans? Okay, so homework, classwork is on Canvas. I feel like I need to do one with you.
Steel said it was, I asked Steel, wait, my brother said it was so easy.
I told you that. I make it look so easy, but it's amazing because
You are a teacher. You
Okay, look. So I don't know what I was doing. I was getting my rhythm going. You made me lose my thought here. I was trying to cha-cha. Oh, here we go. Cool. So there's one of them. Here we go. This is the first one. So I will do one with you. Pick one from these 6.
3.
Take a look before you blurt out numbers.
5.
Watch out for the golf ball.
5.
Okay.
Oh yeah.
Raise your hand for 1, 2, 3, 4, 5. You guys just wasted your time. Go ahead. You wasted your problem.
Wait, what was the right one? Wait.
You guys ready?
Wait, can we do Matthew then?
I'm going to do 5 because that's the one you picked.
Let's do Matthew. Matthew picked number 4. You raised your hand.
But I have to tell you,
Yeah, me too.
1 person raised their hand for 4.
And it was Matthew. That's freaking cool.
Okay, you know what? I'll do solid. I'll do 2 of them with you.
You get to pick the next one.
No, you guys said 4, right?
Yes.
62 plus
I said 4, not you guys. I said 4.
Okay. Oh my God, what is this? This looks crazy.
It's gonna.
Now.
No, it doesn't, because Y and X are the same thing.
X, my friends, is a central angle. Therefore, X is equal to 70.
Oh my god.
Well, that was easy. Now, Y. Y is an inscribed angle. Therefore, it's half of 70. Y is 35 degrees. And you're done.
I'm done.
Why did you do this?
Because I probably would not have gotten it.
Yes.
Even if like the inscribed angle isn't like right behind the
No, it's inscribed is inscribed. As long as the vertex is on the circle, it is an inscribed angle, my friend.
My
Michelle.
friend.
Oh,
And it has to touch your Okay, it has to touch your
I like the cha-cha. So, do you guys still want 4 then?
yes.
Yeah, sure.
Which one was hard? Here, pick it.
No, it didn't sound like there was one that was
Do
really
the one
hard. Like
Matthew
you
picked,
wasted
number
it.
4.
I didn't pick it. I heard he kept saying 4. You guys want 4? You see it now? Once you saw 1, you saw them all, didn't you?
Yes.
Once you saw 1, you saw them all. So,
Oh, wait.
that's a 62.
Yeah.
Okay, so you're finding X. 62 is an inscribed angle.
Yeah.
Therefore, the arc is twice as big, making it 124. Therefore, X is a central angle. It too is 124.
Okay.
Alex like, no. I'm waiting for the catch here. No, that's it.
Wait, can you go on over number 5 again?
He said, y'all wasted your question.
Yeah, that's what confused me. I was like, oh no, we should have.
X is a central angle, so it's going to be the same as the arc. That's why X is 70. Y is an inscribed angle. See how the vertex is on the circle? That angle will be half of its arc. So half of 70 is 35. That's it.
Is there 2 pages? 2 pages.
There are 2 pages, so if you want, I'll help you with one from the other page as well. Yeah?
Yeah. Shush.
Yeah.
Yeah.
Okay, pick one from those 6.
Whoa.
Alright, guys, think this one through.
Number 5. No.
The way you did that was great. That was crazy. That's gross. Oh my god.
What does number 7 look like?
That was a great question.
Oh.
Hey.
No, we just put up our
No,
problem.
but 8 has like the
Just
parallel, and then
1 through 10.
Yeah, let's do it. No, 10.
10.
10.
Yes.
Literally, it's going to be.
It's a vertical.
He laughs at us because they're all easy to him.
They're not all easy. I get stumped sometimes too. Because I think these are all like just big puzzles to me. And wait till you do big circle. Did I show you guys big circle yet?
No. Is that like big bird?
No, Miss Goodness, if it's gonna confuse me, let's not go over that.
Right now you're starting with the baby steps. The next thing we'll do is going to be called the big circle. And let me see if I can show you what a big circle looks like. They're called big circle problems. Big circle problems.
Big circle.
Are you sure? Who doesn't love math?
I don't know who you are, but.
So here's what big circle looks like. It'll start like this. And guess what you have to find?
What was the answer?
All of them, 1 through 20.
What the hell? Oh my god.
I will
Well,
put this
it's
in
like
your-
It's not
When are we gonna do this?
Look, I got a zebra.
Just a bunch of
so
scribbles.
ugly.
This is ugly.
Yes.
You break my heart. But it's not bad. Look, because here's what I know. I know there's 360 degrees in a circle, right? Okay, so that means that this arc here is simply the difference between 85, 150, and 40. So how much is this arc?
192.
That's 75.
But see, here's how you start. It goes one piece by one piece. I've got that, right? That's going to give me angle 4 because angle 4 will be half of that, won't it? Do you see how that starts going? And then you start. That's an inscribed angle, bro. Look. See it?
And then you
Wait,
have
but
center
what?
point.
So then once you have that, then you're going to start building on pieces of that. Exactly.
150 plus 85 is 40.
So that angle would be the same as this angle. And it just builds and builds and builds and builds, and you start developing the whole big circle problem.
What's that?
It's called a big circle. Okay, so. Okay, you asked for this one?
Yes, please.
These two intersect on the inside, don't they?
Yeah.
So what needs to happen? I need to add the two arcs and divide by 2 to get that angle, don't I?
Wait, but is it 53 because of vertical angles?
Well, I'm looking for the measurement of arc BD. You see that up here? Find measure of arc BD. So I need to find this measurement right here. So what I need to do is solve for x first.
Wait, what is it?
Because it wants you to find x. It's giving you it's giving you the length in a formula, so it's making you find a piece of it,
Are
which
we
is
gonna do that
pretty messed up.
thing that's like when you do this and you put the X on
Proofs?
one side? Yeah.
Nah. Here, well, we can. Let's do this real quick. I know that I've got to add those two angles. So I have to take the top angle, which is 3x plus 3, and then I need to add it to the other angle, which is 10x minus 14. Divide that by 2, and I should get how much? 53. I should get that angle, don't I? So that's how you go about setting that up.
But how do you know it's? Can you like actually like work with the thing and then?
I'm going to just solve this. So let's go and start off. You guys want to clean up the top
No,
first?
but how would you know it's 53?
Because they gave you the angle. It's right there. That's the angle.
LOL.
JK.
Yeah.
All right, cool.
Yeah.
So let's see here. 3x's and 10x's gives me 13x's. So I've got 13x. 3 minus 14 is negative 11. Divided by 2 is still equal to 53. I'm going to multiply both sides by 2. That'll give me 13x minus 11 is equal to 106.
Yeah.
Add 11 to both sides. Addition property of equality.
Wait, were you supposed to multiply by? Were you supposed to multiply the 13x and the?
Oh no.
Or no?
No, because it cancels, doesn't it? This quantity times that quantity, it'll cancel out. I'm just going to say them. But I do want you to get, if you're not writing them down, at least say them to yourself and know what they are. Okay, because at some point they might just ask you. Remember I said anything is fair game? So if they ask you something to say, solve this equation, and they say, what is this property called, then you need to know what it's called. Okay? So I'm at here. Sweet. Thank you, boss. Oh, El Signatura. 117 people?
Yeah.
If you divide by 13, it's like
It's 9.
sweet beans, sweet beans, sweet beans. Cool beans. So X is 9. We want that arc. So go ahead and plug that back in. So 90 minus 14.
Here you go. Oh my god, that's
Oh, well, how's that gold treating you, man? Yeah, it's crazy.
Doesn't let go.
Thank you very much, sir. Have a good one.
Christmas gifts.
Can you put water on our feet?
No, I thought you got a pen out of that.
Can you put water?
That song, was that you?
What song?
Yeah.
You don't need that.
Bum.
Oh, thanks. Sorry. Almost.
Munoz. Pop it.
Yeah.
Oh. I'm just making sure that I loaded everything.
My mom has to keep those.
Okay, guys. Thank you. There's your practice here. Let me put the full screen on. You guys can copy that. The homework is on Canvas already, and I want to kind of just do some housekeeping. Once you submit your homework on Canvas, keep it. I think Riggs made a great point that that's all you really have to study. So I want you to make sure that you have that and that we go over it. So I want you to go home. You do your homework. You submit it via Canvas. Whatever questions you still have left, we'll go over together as a class. So that way your homework should be completed, should be 100% no doubt, correct?
So we don't put it in there.
Yeah, don't put it in there anymore, because all I'm really gonna do is just go ahead and check mark as well again, and then I put them in a box, and it's a completion homework, did you do it or not? So give me that, I'm gonna trust that you did the whole thing, and if you're not, then you're not taking advantage of the class, you're not forcing yourself to do this, so. Yes, you can. Yeah, and all I really want is proof that you did it. That's all I really want.
Jacqueline, I put mine in Steele's homework on my thing.
So is there any questions on
It
that?
was like 4 pages.
So don't worry about putting stuff in the cubby anymore. Keep it. I want you to keep it in the binder so that when we get to the end and you need to study, or you need to study again for another test, you have that material to look back at. Okay? So thank you, Riggs, for that. I think that was a great idea. So we'll do it that way now. Just submit your homework. Once it's in there, we're good to go. Now, if you can't submit it via Canvas, you'll have to bring it to me. I'll have to see it. I'll check it off. I'll give it right back to you. At that same, it'll be a quick transaction, okay? Sweet. The rest of the time is yours to work on this. Please take advantage of this time. I'm here. Your peers are here. Work through it, okay?